Good day, ma'am. So I will be discussing about semiconductors. So semiconductors are a special class of elements having a conductivity between that of a good conductor and that of an insulator, which makes them the foundation of modern electronic devices such as computers, integrated circuits, and digital systems. So in general, semiconductor materials falls into one of two classes. First is the single crystal, and second is the compound. So single crystal semiconductors such as germanium and silicon have a repetitive crystal structure, whereas compound semiconductors such as gallium arsenide, cadmium sulfide, gallium nitride, and gallium arsenide phosphate are constructed of two or more semiconductor materials of different atomic structures. So, what are the three materials mostly used for construction of electronic devices? So next is germanium. So germanium was widely used in the first decades after the invention of the diode in 1939 and transistor in 1947. So its advantages. Germanium is relatively easy to find, could be purified to very high levels, which is important for making electronic devices. However, it also has its disadvantage. Um, it is low reliability due to sensitivity to temperature changes. So next is silicon. So silicon is the first silicon the first silicon transistor was introduced in 1954. It is much less sensitive to temperature than germanium, and it is also abundant on Earth, which is easy to source and manufacture. And during this time, the manufacturing and design technologies steadily improve, leading to high sophistication and nice, good performance. However, it also has its disadvantages. First, it is its per I mean its first is its poor performance at high temperatures and low electron mobility. But as time moved on, the field of electronics became increasingly sensitive to issues of speed. Computers were operating at higher and higher speed, and communication systems were also operating at higher levels of performance. Uh, this is why a capable semiconductor that could meet these new needs had to be found. And thus, the creation or the development of the first uh, gallium arsenide transistor was made in the early 1970s. So gallium arsenide is uh, much better compared to the silicon because it operates in a high-speed operation 5 times faster than of a silicon. However, it also comes with a disadvantages. First, it is difficult to manufacture at high purity, more expensive than silicon, and initially had limited design support. So let's move on to discuss covalent bonding and intrinsic materials. So covalent bonding is a type of atomic bonding that holds semiconductor crystals together. In materials like silicon, germanium, and gallium arsenide, atoms share their valence electrons with neighboring atoms to satisfy the octet rule and achieve a stable electron configuration. Silicon and germanium have four valence electrons, allowing them to form four covalent bands and with nearby atoms. And in gallium has three valence electrons and arsenic has five. So in gallium arsenide, the electrons are shared such that each atom effectively complete its outer shell. And these shared electrons are localized between atoms, forming a rigid crystal lattice. At absolute zero temperature, all valence electrons are bound in covalent bands, so no free charge carriers are present. So let's move on to intrinsic semiconductor materials. So an intrinsic semiconductor is a pure semiconductor material with very low impurity levels, and free charge carriers are generated only by thermal energy or external energy, example, light. Light. When a covalent bond breaks, an electron becomes a free conduction electron, leaving behind a hole. And in an intrinsic material, the number of free electrons is equal to the number of holes, and the material remains electrically neutral. As temperature increases, more covalent bonds breaks, resulting in an increased conductivity, which gives semiconductors a negative temperature coefficient. So I will be showing you a drawing of the atomic structure of silicon, germanium, and gallium arsenide. So what is a valence shell? A valence shell is the outermost electron shell or the energy level of an atom containing the electrons or the valence electrons most involved in chemical bonding and reactions. So what is valence electrons? Valence electrons are the electrons located in the outermost shell or located in the valence shell of an atom. They are crucial because they determine an element's chemical properties, reactivity, and its ability to form bonds with other atoms. So, what is tetravalent? Tetravalent are atoms that have four valence electrons. So, four valence electrons is called tetravalent. Next is trivalent. Trivalent are those with um, three valent electrons. So, trivalent with three, and lastly, pentavalent. So, pentavalent, which comes from the word penta, means five. So, five valence electrons. So, next I will be showing a drawing of a covalent bonding of the silicon atom and a covalent bonding of the gallium arsenide crystal. I guess that's it. Thank you, ma'am.